We're Group 5 and we did sustainable golf course design looking at Hawks Landing. So the USGA set up some outlines for what an environmentally sustainable course should be. So it should be environmentally responsible while remaining economically viable and also use resources efficiently. It should maintain playability while using practices that preserve the environment, and then it should offer and protect habitat for the wildlife of the area. So today we're going to look specifically at some bunker alternatives. Then we're going to examine fairway maintenance and the use of crumb rubber. We're going to look at tee box construction and greens, and then we're going to look at stormwater management and finish with a brief life cycle assessment.
Alright, bunkers are an integral part of the golf course, and bunker sand needs to be set up correctly to ensure good playability. If bunker sand is too hard or too soft, balls can end up getting plugged in the faces, and this causes problems for playability. So the U.S. Golf Association has set forth some recommendations for the particle gradation size. As you can see in the red box, they set up, they want about 65% coarse sand and medium sand, and after testing Hawks Landing sand, we found that they had about 75%, and the USGA recommends more than 65, so that was good. And there's also 12% of fine and very fine sand, which is below the 25% recommended. For silts and clays, they recommend having less than 3%, and Hawks Landing had about 4%, so it's a little over, but it's still near their recommendations. Other important aspects of bunker design is hydraulic conductivity, which is just how fast the water can drain from the bunker, and another is a mix of angular and round sand. This really helps to have steeper slopes, as the mix of angular sand can increase slope stability. And part of the analysis we looked at was the sand in Hawks Landing bunkers appeared to be a lot more round, which can lead to more washouts. This is the particle gradation curve from Hawks Landing. As you can see, most of the particles fall within that recommended 1 to 0.25 millimeter range, and it roughly meets most of the USGA guidelines. And to further go through the elements of bunker design, the sand in the middle of the bunker is about 4 inches thick, and then on the edges, with steeper slopes, it's about 2 inches thick, and then below there's a 4 to 8 inch layer of gravel to aid in drainage. And then it also features a herringbone drain tile system that you can see in the picture on the right. And this is also to help aid in the bunker drainage process. Over time, bunkers accumulate silts and clays as they wash from outside of the bunkers, and it can decrease drainability, and it can also this can also increase washouts. Here are the bunkers on Hawks Landing Golf Course. As you can see, there's the bunkers in yellow are problematic, and there's 4 priority bunkers that experience a lot of washouts, 17, 5, and 1. This is an example of a washout. As you can see, all the sand from the slopes has washed down the face, and there is poor drainage, and a lot of silts and clays can be seen in the center, and this had to be repaired. This is on hole number 1, bunker 4. And now Brian is going to discuss bunker alternatives.
Alright, so now that we discussed some of the issues with bunkers, we looked at 3 different alternatives which could possibly solve some of the headaches that are caused to the greenskeeper. The first alternative is replacing the current sand with all new local sand. The second is using a polymer layer, which is becoming increasingly popular around the nation, as well as possibly using crumb rubber tires to be installed as a drainage layer for the bunkers. Now the first alternative entails completely removing the current sand in place and bringing in completely new, fresh, clean sand. This would accomplish the effective cleaning of the old sand So instead of having the old sand, which Justin pointed out had a bunch of clay and silt in it, this new sand will be relatively clean, as well would provide better drainage since there's more pore space and a higher permeability. The second alternative, which I said is becoming more popular, is this polymer layer. So as you can see on the bottom, it is sprayed on the gravel layer beneath, and what this does is when it percolates down to the rocks, it dries and forms this hard plastic layer, which not only prevents smaller particles from falling in between the cracks, but doesn't allow the gravel to move separately. So if it moves, it has to move it as a sheet. And we really looked at two different designers. There's the Billy bunker and there is the Stay Lock bunker. The third alternative was, like I said, is using crumb rubber. This is attractive to us because scrap tires are beginning to pile up in landfills and they don't really have a great use for them. So since there is a surplus, it is economically beneficial to use this crumb rubber as a drainage layer. Since most of the crumb rubber are consistent in size, you don't need to worry about smaller pieces falling into the bigger pore space and sacrificing drainage. You could really have an efficient drainage system with this crumb rubber. Now, in order to compare all three alternatives, we ran an economic analysis. Some of the assumptions that we came up with were that a year would be the 25-week season, or however long the golf course would remain open. The second is that the labor cost would be $9 an hour, and the third one is that we would be working with a 20,000 square foot bunkers area. Now, as you can see here, the most expensive option we came out with is the Stay Lock polymer, but using new sand, and the cheapest is using just new sand in general. However, the Stay Lock is nice, but the Billy bunker accomplishes the same thing, and the new sand, although cheap, only really helps us in the short term because as soon as a big event comes, more silt and sand, clay particles could potentially fill these cracks and increase the amount of standing water at a given time. So with that said, we were recommending using the Billy bunker system coupled with keeping the sand there that is currently there. As you can see in the picture right here, this is the same course with one non-Billy bunker and one with a Billy bunker. This is post-Hurricane Irene. As you can see around the edges, there's a good deal of washout happening, as well as a good deal of standing water. While the Billy bunker on the other side has no water in it, no debris, and there was no washout during this process. The Billy bunker is proven and it is becoming an increasingly popular product and was actually recommended to us by the greenskeeper. Now with that, Joel will come and talk to you more about the fairways, tee boxes, and greens.
Alright, so after talking with the greenskeeper at Hawks Landing, this is basically the way that they take care of their course, and they do a very good job of being sustainable with their course. So after talking with him, he basically told us that the greens are sprayed every 2 weeks, the tee boxes every 3 weeks, and the rest of the course, the fairways and everything, are basically sprayed as needed. And then these are some of the pesticides that are used on the course, and he uses them at either the recommended rates or in specific amounts based off of previous experience, and then he'll also use it as spot treatment, basically just as needed. So the course is made up of creeping bent grass, and that's used for the tee boxes, greens, and fairways. And the rest of the course, the rough, is made up of Kentucky bluegrass, and the drainage system for this course goes in the pond. So this is basically a standard fairway profile, and Hawks Landing is very similar. But one thing that we were going to propose is to use a 2-inch tire layer just above the drainage layer. And because Hawks Landing is a fairly established course, to say that we are going to go in and tear it up and make these subtle changes to try and make it more sustainable wouldn't be the best decision right now. But it's simply a proposal for maybe future ideas. So why use scrap tires? Well, as the water basically percolates through the ground, it'll be absorbed by some of the chemicals and pesticides will be absorbed by this tire layer. Tire rubber has been found to absorb organic compounds, including pesticides and nitrates. And according to a study done by our professor Jim Park, it shows that a 20 centimeter thick tire layer was able to remove 90% of the initial concentration for 30 out of 51 pesticides it was tested on. So that shows how effective this could be as a way of basically removing chemicals and stuff from the water, and it would help reduce the amount of harmful runoff. So the ground tire application would be made up of a 2-inch layer just above the drainage system, and in doing this you'd want to use uniform small pieces basically to increase porosity and allow the water to flow through easily, and it would help increase the drainage and basically filter out the groundwater as it moves through. Now for maintaining the fairways, they spray them basically as needed. It's not like the greens and the tee boxes where it's sprayed more consistently. The fairways are sprayed with the different types of chemicals that was showed on my first slide. And these are all different types of mildewicides and fungicides, and they help the grass grow strong and steady. But they can also be toxic to humans and aquatic life, so it's important to use them as needed or at only the recommended rate. And they're used to help prevent things like this. This is a picture of dollar spot disease, which is an issue that they've had at Hawks Landing before. And dollar spot disease is dead and miscolored spots in the grass, and it's caused by a fungal organism. So by using some of these pesticides, it can help prevent a disease like this. Also, we're going to propose a top dressing layer, which is already in place at Hawks Landing, but the idea of the top dressing layer is just a 1.5-inch layer of sand spread evenly across the surface of the fairway, and it helps reduce compaction and increases porosity so the fairway can drain better, and you won't have that standing water and issues like that after a big storm. So this here is a picture of a sand-capped fairway as opposed to an uncapped fairway. And as you can see in the picture of the sand-capped fairway, it takes a much cleaner divot, and there's not a bunch of residue left on the club face, and also it stays out of the organic soil layer so the grass can regenerate a little quicker. As opposed to the uncapped fairway where it does take a little bit heavier of a divot, leave some of the residue on your club face, and can make it tougher for the grass to grow back. And I'm also going to talk about tee box construction. As it shows in this picture here, tee boxes are generally really squared off and large and flat surface areas, so you want to make sure that you can build up that ground without using too much backfill. So we are going to propose the use of tire bales. Tire bales consist of about 100 passenger tires, and they're made into a 2 cubic yard block, and they're very strong, very sturdy, so they can be used as backfill to kind of help build up the ground. It can also be used to filter out the pesticides as water is running through the tee boxes when they're sprayed. Installation will be done basically as pictured here, where you would just stack the tire bales as needed on the base layer on the compact subgrade, and that would make for a very nice sturdy layer in your at the base of your tee box. Now I'm also going to talk about green construction. This here is a picture of a standard green profile, and it's very similar to the fairway profile where it would be the sand layer followed by the organic soil layer. And the thing about greens is they need to be very well kept and very consistent because the greens can really affect the playability of the course and the quality of the course overall. At Hawks Landing, creeping bent grass is used for the greens, and they do a very good job of keeping them consistent. And for green sustainability, like I mentioned before, it's important to basically conserve water and be as sustainable as you can in that respect, and to spray the course as little as you can. But when it comes to the greens, it's really important that they're in very good shape. So like they do at Hawks Landing, they'll spray them every 2 weeks and they're watered a little bit more. And that's the way it really needs to be to keep the course up to standard and to keep the greens up to standard. And now Josh is going to talk about the stormwater management.
All right, and now we're going to talk about stormwater management, which was another aspect of sustainability design that our group looked into for Hawks Landing Golf Course. And the 4 kind of different areas that we kind of really focused on were the scrap tire berms, pond aeration, rain gardens, and water reuse and recycling. And so, just a little background. So as far as the area for if we were going to do construction, we needed to look into the soil type. And from our research, we found out that the soil underlying the golf course was dominantly silty loam, which will be good for the scrap tires as far as having to do with pesticide absorption. And so this is hole 7, which is one of the 3 ponds that we looked into for doing water reuse for irrigation. So it'd be hole 7, hole 18, and then hole 10. So hole 7 is just this red line, just shows ideally we'd have a berm constructed surrounding the pond to prevent stormwater from going into the pond. And so here's a cross-sectional view of doing a scrap tire berm. So we'd have the berm over here, and then we put scrap tires about a foot down below in it, and the berm would prevent the stormwater from going into the pond. The stormwater would infiltrate through the soil, and then the scrap tires would be used as a sort of filtration and basically a way to clean the water and get rid of pesticides and other pollutants. And then this is just another diagram just showing top view or aerial view of what we'd like to see. So you have your pond and then stormwater and then irrigation finally. So looking into the project, as far as the scrap tires for the 3 different ponds, the total perimeter was over 1,600 meters, or it was about a mile. And so that would be the total cost that we had included the excavation and installation of the berm and the scrap tires, and then it also included the cost of the scrap tire. So we had 3 different options. This option was the thinnest layer of scrap tires, which was at 30 centimeters. The second option would have been at 90 centimeters, and then the last one was 180 centimeters. As you can see, the cost, it more than tripled going from option 1 to option 2, and then option 3 it doubled from option 2 to 3. And so our recommendation is that we go with option 1, as you still get, like as Joel mentioned earlier, it's going to be able to absorb like 90% of the initial concentration of the pollutants and the pesticides, but at the same time we're also going to reduce costs significantly versus our other options by going with this. And now, let's see, so that'll be our recommendation, and then now Joel's going to talk about pond irrigation.
Most golf courses in North America use chemicals to treat their ponds for bacteria, algae, weeds, color, and smell. The stagnant under oxygenated water is also bad for wildlife, but greenskeepers try to combat this with the chemicals, which they spend an average of $4,000 to $8,000 per year for North America courses. With that large cost, a lot of greenskeepers are looking for alternatives to take care of their ponds, and one method is pond aeration. And this consists of a diffuser at the bottom of the pond connected to the surface with an air tube that creates oxygenation and circulation throughout the pond. It reduces the amount of algae by breaking down the nutrients that algae actually feeds on, so it takes care of the problem at the source. It removes the need for chemicals, as mentioned previously, and it's safe for wildlife. The only downside of this compared to the chemicals is that a power source is required within 1,000 feet of the pond. So here's a schematic of a pond aeration system with the diffuser causing circulation and oxygenation throughout the pond with the air tube flowing up to the power source. To create a more sustainable golf course, we are hoping to have a renewable energy source as the power source, and we are proposing a windmill. But in order to determine if a windmill is probable for this site, we need to do a wind analysis. So we use a nearby wind distribution of 3 heights, a nearby wind station with a distribution of 3 separate heights at 28, 39, and 50 meters. We need to determine if at the site we have a 3 to 5 average miles per hour wind speed. So to do that, we have weighted average the 28, 39, and 50 meters, and we're going to vertically extrapolate them down to our hub height. So by using the log profile and the power log and 2 separate hub heights at both 5 and 7 meters, we determined that the average wind speed is between 9 and 10 miles per hour for both. So with that, we have 3 separate ponds at Hawks Landing, which was mentioned previously. And the biggest benefit about this system is that we can implement it 1 pond at a time. So we can actually implement one pond and determine its actual effectiveness of cleaning up the pond in order before we invest even more money into the system. But it does have a short payback period, about approximately 3 years, which is offsetting the chemical cost that the greenskeeper would be spending annually. And it also has renewable energy. Instead of connecting it to the power source that the golf course currently uses, which is the utility, we have free renewable energy for our diffusers. And with that, Cal will talk to you about some rain gardens.
Okay, the next aspect of our sustainable design at Hawks Landing Golf Course is the aspect of rain gardens. We plan to implement rain gardens at various locations throughout the course to help filter surface runoff. So rain gardens are specifically designed gardens in low-lying areas that collect the rainwater and runoff from impervious areas, such as roofs or parking lots. They're composed of native plants and grasses. The Wisconsin State DNR recommends a list of over 50 plants and grasses that can be used in rain gardens. And they prevent erosion, remove oils, pesticides, and other contaminants. And they may remove up to 30% of the potential contaminants in the groundwater. So to complete our rain garden analysis, we collected a topographic map and overlaid that upon a Google Earth image of Hawks Landing. So the first location we identified as a problem area and a potential rain garden location was next to the clubhouse and by holes 1 and 18. This was identified as a possible location due to the high amount of runoff from the clubhouse roof and also the parking lot. The rain garden would help with erosion from the runoff and also to collect some of the oils and contaminants that could run off from the parking lot into the pond at holes 1 and 18. The second proposed location is near the pond on holes 7 and 8. On the far side of holes 7 and 8, the County Highway M and Midway Road intersect, and therefore we have a lot of runoff that will come from those roads. The rain gardens can help filter some of the runoff, the litter that comes from the road, and hopefully provide a small barrier for some of the sound that comes from the road, providing more peaceful and beautiful experience for the golfers at Hawks Landing. The next aspect of sustainable golf course design I'm about to talk about is pond water reuse and recycling. Currently, Hawks Landing uses 17 millions of gallons per year of water for irrigation at a cost of $2.19 per 1,000 gallons. That is a total cost per year of over $37,000 for irrigation and water use. Options for water cost reduction are utilizing the pond on holes 7 and 8 to water those holes. Currently, Hawks Landing uses the pond on holes 1 and 18 to water the holes, and that helps with the cost. However, that system could also be implemented on the various ponds throughout the course. Another option is using reused water, which is treated wastewater from the city that can be used for irrigation on the course. So, like I said, we would like to propose that the pond on holes 7 and 8 be used for water reuse. This means that stormwater that is collected in the pond after each event will be collected and then used for irrigation on the course. This will result in an 11% reduction in water use and therefore over $4,000 in savings per year. This means that the system will be paid off in one fiscal year, and therefore we believe it's a very economic and sustainable solution for Hawks Landing Golf Course.
Project, it's always important to do a life cycle analysis. In this case, we looked at fertilizer and pesticide use using the Economic Input-Output Life Cycle Assessment tool provided by Carnegie Mellon. Since the greenskeeper was unable to give us exact values for the fertilizer and pesticide spending, by looking at other courses, we estimated values of $45,000 and $40,000. So that is the 100% case that is represented in the table here. And then we also looked at two other cases, a 25% reduction in use and a 50% reduction in use. So the table summarizes some important findings from this assessment. In the first row is the total economic impact. This includes direct and indirect costs incurred in the production of these chemicals. The rest of the rows list environmental impacts, including the energy use and water use. So based on our findings, we recommend a 25% reduction in fertilizer and pesticide use. This is it's obvious that there's a reduction in all of the impacts, and 50% would reduce it even more, but since for a golf course it's very important to maintain playability and keep it decent looking, it's unsure how much reducing it by this much would affect these things, so therefore it's not recommended. And with that, we conclude our presentation, and we thank you